Okay, welcome everyone, and thank you for joining today's session. Um, to start, I am Vikas. I am a co-founder and software consultant in Inzint, and today we are here to have a masterclass on Python. So this class is going to be very informative, and people have been waiting for this class for a long time. Finally, the date was postponed at one point in the past, and because of the reasons that we could not avoid, finally we are here. The session is happening today. In this 1 hour session, we are going to learn Python's basics, the fundamentals, the loops, the control flow statements, and functions, and also the different data structures that we have in Python. So I will cover all of this in theory as well as and as well as demonstrate everything with program. Yeah,
Yes, sir.
cool. So few important rules. One, I all the participants in the meeting in the session will be muted by default. So when you have a question, you can unmute yourself and ask in between only. Okay. Anytime, feel free to interrupt. Feel free to unmute yourself and ask the question. Asking the question is appreciated, and it's cool. So, all right. So here we go. First, introduction. Um, Introduction to Python. Python is a language that is based on interpretation. How that works is that while most of the language in the market work are compiled language, Python is not. So basically, compilation works like this way. If it is a Java program, there is a compiler which runs the program and converts it into a byte code, and then it is executed. Compare this area on the top. This shows how Java program executes. The other area is down in the below. It shows how Python program executes. Python instead uh, is interpreted language, which means every line of the Python is directly executes. It doesn't require a compilation. So it's good for simple instructions, straightforward, simple programs, because you do not have to compile every time and run. Hmm? And also where you also in Python, it's easy to execute every line and see the output. Whereas in compile type languages like Java, you cannot run every line and see the output line by line. What I mean to say is that here is a Python editor. I'm showing you what I mean. I'm saying I'm assigning a is equal to 2. Now, right in the next line, I can simply print and see what's the value of a. And then in the next line, I can say b is equal to 3. And again in next line, I can check what's the value of b. And then I can say a is c equal to a plus b. And then I can check the value of c. This is how the Python's behavior is. Like every line you can see the output, but that's not how it works in Java, or any compile time language. There you need to um, compile the entire program and then only see the output of the whole program. Yeah, that's the big difference. It has got some advantage. Both the sides have got their advantages and downsides, but that's not a discussion for this session. Now let me tell you about the basic some of the basic keywords that we will be using here in this session all the time. When we meet code or source code, this is a sequence of instruction in a program. What it means that in this example, every line is an instruction. Instruction means we are giving this instruction to the computer. Okay. And when we say a program means a set of instructions. This means all of this put together from a equal to
Sir,
2. Yeah, please.
in Java, after the compilation, the code converted to bytecode. Using that bytecode, we can run into different machine. Like if we code in Windows, then we can run that using that bytecode in Mac also, sir. Like Python also, we can run like that. It's
Yes,
in Python. It's in platform independent.
yes. Python is also platform independent, and Python interpreter takes care of that platform dependencies. Hmm?
Okay, sir. Okay, sir. Thank you, sir.
So all this set of instructions from a equal to 2 to final output of C, this together makes uh, a set of instruction as a program. So that's what a program or source code means. Now there's other word called syntax, very important. The syntax means the structure, defined structure, how a program should be written. Hmm? Very much like grammatical rules you have in any human language, the syntax works like that way. Output, output is the final output that is printed out of the program. And when we say console, console is a text box into which we our output is printed, or we also give input through a console sometimes. Okay, I will so demonstrate all of this in real world. I also like to introduce you to the editor that we are using. We are using this editor called Google Colab. If you haven't used this before, it's easy. You can find about this right here, Google Colab, and search for it. The second link here, or the first link also works, like both are same thing, is Google Colab. When you open this, it will ask you to open a new file, and it looks like this. Okay, so I'll delete what I have written just now. This is how it works. So it has got multiple cells. If you want to add one more cell, you can just go and create, go to insert and click on code cell. It will create another cell. Every cell can contain multiple instruction or single line of code, as you like your choice. Okay, we talked about compilation versus interpretation. Okay, so now coming to Python. Python is an interpreted language. Its interpreter provides the interactive environment to play with the language. This is one of the very important, like every line you can see there is output. And this makes like programming easy. And the results of the expression are printed on the screen. Now next is expression. Expression are nothing but simple arithmetic expression, simple mathematical expression. In you must have heard the word expression in your mathematics class. So anything like 2 plus 4 is an expression. So this is an example. 1 plus 4 multiplied 3 is an expression. Okay. So if you want to use an expression, you can write here 1 plus 4 into 3. And in Google Colab, if you do shift plus enter, it will run the cell and it will give the output. This is a mathematical expression we are talking about. Okay. Also, when you have multiple operators in an expression, for example, in this expression, we have got two different operators, the plus operator followed by a multiply operator. When you've got multiple operators in an expression, the board mass rules applies. For that reason here, it's not 4 plus 1 5 into 3, it's like 4 into 3 first, then added to 1, and that's the reason is 13. Is this making sense to everyone?
Yes, sir.
Okay, great. Okay, so here we have got the precedence. It explains what I just explained. Like first, 3 is multiplied to 4, that becomes 12, and then added to 1, which is 13. Hmm? If we wanted uh, 1 plus 3 to happen first, what we would do is that we put this part in parentheses. Now this will 1 plus 4 will be solved first. This will become 5, and when multiplied to 3 it will become 15. Okay, in Python we have got two different types of division. One is using this single slash. When you divide two number using single slash, it gives you the quotient. Okay, so for example, when you divide 4 by 14, the quotient is 3, because 4 3 times is 12, and that's the whole number which divides 14, which is close to 14. And then there is remainder 2. So when you say like 14 divide by 4, it will always going to give you 3. The remainder is discarded by default. There is another operator called modulus operator. This modulus operator looks like the percentage sign in your mathematics. This modulus operator is going to compute only the remainder, which means when you do 14 modulus 4, it is going to return 2. Let's look at this in example. 4 modulus 2 returns 0. Why? Because when you divide 4 by 2, the remainder is always 0. Let me show you another example. 14 divide by 3. When you divide 14 by 3, 3 4 times is 12, and that's the biggest number close to 14, which is like divisible by 3. Sorry, okay, this is how it works. So this gives you the quotient, and this modulus gives you the remainder. And there is another way to do it. Now when you do 14 divide by 3 using single divide sign, it's going to give you the entire number like 14.667. This 14.667 has taken care of all the quotient and remainder both. So there are three ways you can do perform division here in Python. Till this point, any questions, any doubts? Okay, so let's move to the next part of it. Uh, Python is the only, probably only
Sir,
program. Sorry, yeah, please go ahead.
sir, we about the data types, sir. In Java, we use double to declare that decimal numbers, integer, long.
Yes, okay. So here we also have got two different data types, multiple different data types which are supported by the Python natively. And there are a couple of data types that you can make by yourself. Okay, so depending upon the size of number, you also have integer, long integers. So, and that thing we are coming to later in this session.
Okay, sir.
Hmm? Yeah, we also have floating point numbers and integer everything. Cool. So yeah, we were talking about the real numbers and imaginary numbers. Python probably in the modern day is the only programming language that supports both type of numbers, real number as well as imaginary numbers. You must have studied imaginary numbers in your high school. So imaginary number is basically root square of -1. So okay, so here are some examples of real number. Real numbers, all of these are examples of real numbers. And all the operator plus, minus, divide, double divide, or modulus, asterisk are all going to work on this real numbers. Python is very compatible with the mathematical commands. So, and it has got a very rich library of the mathematical operators. So these are the all mathematical operators. I have here is a link of Python's math function, math library. When you import the library, you will be able to use all the mathematical functions. There are a lot of them. You can read about their description as well as their examples. uh, I've got some covered here in the slide, like absolute will give the absolute value. If, for example, absolute of +2 or -2 is always going to be positive number. Basically, put it simply, this command, absolute command, is used to convert ignore the sign of the number. This means, if sometime you want to ignore the number being +2 or -2, you can use this number. Ceiling, you can use the ceiling value when you want to possibly get to the higher value out of the get the higher value and ignore the lower value. Let me show you an example. Okay, the first line we are doing import from math function, and then we assign it a value -2.34009. When we print this absolute value, it's going to print 2.34009. It's going to ignore the minus sign. Okay, now other one, ceiling, CEIL. If we do ceiling of this value, and let me also remove minus, so ceiling value of 2.34009 is going to be 3. How this works is that anything after 2.0 becomes 3. That's what ceiling means. This is different from round, where round will become a higher number if it is more than 2.5, and it is less than 2.5, that it becomes it will remain 2. That's how round works. And ceiling works little differently. And there is also this called floor. Floor will make anything between 2.1 to 2.9 as 2. Okay, it takes 2.3 as 2, and also it will take 2.9 as 2. So as long as it is 2 point, even if it is like a little small dot less than 3, it is always going to say it is 2. So floor and ceiling are completely opposite in nature. Is this making sense till this point?
Yes, sir.
Okay, good. um okay, so very important, if you want to use any of these mathematical function, it's important that you write the import library here and on the top. Okay, floating point numbers, here we have, and it also talks about typecasting here. So if you want to convert a floating point number into integer and integer into floating point, you can use these things here. For example, if it is a floating point number and if I want to typecast into integer, let's look at example. Okay. Oh, before we talk about this, I also need to introduce you what floating point numbers means. So a is equal to 2.56. This is a floating point number. Okay. And integer is something like b is equal to 9. So no decimal, no points. It is integer. It is called integer, and decimal and points are there. So it is called a floating point number. Okay. Now it's time to convert one into another. So if we need to convert b into floating point number, I will say float b. This we have weirdly. Hmm. X into a floating point number. Oh yeah, float 2 should be 2.0 and int 2.0 should be 2. Um, Hold on, float. Okay, this is how it is. Yeah, this is how it is. So now b is an integer. When we want to convert this into floating point number, we will use this syntax. We will say float b, and it will convert b, which is 9, into a floating point number that is 9.0. Opposite, if we want to convert a into integer, we will say int a. Hmm. When we convert int a into a, which was a floating point number first, we convert it into integer. It prints just the integer part of it. Cool. Any questions or doubts till this point? All right. So there is plenty of mathematics involved in Python. If you have a good understanding of mathematics since your high school days, it will be quite easy to understand. If you missed mathematical concepts during your schooling days, it's good that you brushed them up now. Nice. Now we are talking about variables. Variables are basically a memory units that can store value. So in your computer memory, they are like a container. They can contain a value that you want to store inside them. So we have been using variable for a long time in our examples. For example, a is equal to 2.56. Here, a is a variable. Why we are calling it a variable? Because a is acting like a container which stores 2.56, and a can also change its value. So first we say a is equal to 2.56, and at later stage if we say a is equal to 0, now the value of a has been modified. And that's the nature of variable. Variables just act as a container. You can keep any value inside them. Let's look at this for in our example. So because a has changed its value, when you try to print it, it always says 0. All right. Let me give you an simple example using the concepts that we have learned so far. Okay, so here is an example. Age, on in the screen it is visible. Uh, Here, age is a variable. Okay, and here we have taken an input from the user asking how old you, which means we are asking the user their age. And when the age is stored, we print how many years are remaining for their retirement. Let's see how this works. I run the program. It is asking me how old are you? I said I am 45, and then I hit enter. It says, oh, you have 20 years until your retirement. Okay, so this demonstrates how we can accept input from a user, also how we can calculate, and also how we can print. To make it simple, we can also add one more step. Instead of this remaining equal to this, simple, say three different steps. Okay, one important thing to note here is that 65 is an integer number, it is an integer value, and also age is an integer value. And then only this minus operator can operate on both. All right. Uh, let's move to the next part of it. We have got print method in Python. Print method simply is used to output the value or text on the console. Very simple. For example, if you say print hello world, it's going to print hello world. Mm. Okay, syntax problem. This is an old syntax. Uh, yeah. Print, you write anything. Instead of write hello India, it will be hello India. Hello Delhi, hello Delhi. Now you see this how print is working, and similarly has also been print's application has also been used here in this application. If you have a variable name, you can also combine this in print operator. Sorry, print function. So if I say a is equal to 34, and I'll say today's temperature is 8, it will print today's temperature is 34. We wrote today's temperature is A, but it printed today's temperature is 34. Why? Because A is a variable here, and it's
Excuse me, sir. Am I
uh,
audible?
it's, go ahead, Gautam.
Yes, in previous code, the 54th snippet, you
Mm-hmm.
have wrote age equals to int bracket input bracket how old are you
Mm-hmm.
in this line. Can you please explain uh, the age equals to the int part? Will this convert the input into integer type?
Yes, I'm coming to that right here. So yeah, this is how the print works. Now let's see how input works. So print is in the opposite direction. Print means the system is giving the output. Now to operate as a
Yes.
program, since system also needs to accept input from the user, input from you. So how that input is taken is this way. For example, a is equal to um, uh, a sorry, let me give a different name. Name is equal to input. What is your name? Hmm? Is this clear? So we are asking user to give input. What is your name? And whatever user will enter through their keyboard, that will be stored here in this variable called name.
Name
Now,
variable.
yeah, name variable. Next, I will print
So
this.
it will give output. It will print a statement. What is your name? And then will ask for the user's input.
Yes, exactly. Let's run this program first. Okay. We are saying what is your name? I'll say Vikas. Enter. And this job is done because we are not doing any output, so it has not given
Yes.
any
It got stored in the name variable.
yes. Now it is giving the output. Okay. Now let's try to do the same thing with integer, with numbers. Okay. So for example, if I say a or a input, we have asked their name. Now we are asking this, what is your age? Interestingly, this will accept the age. Now we'll ask what is your age. So this will accept the user's age. But interestingly, the age will be stored not as a numeric, but it will be stored as a integer. The problem with storing a numeric value as string is that you cannot perform calculation on it. Now I show you what I'm doing. For example, we accepted the user's age as a. Next is that I will want to, for example, calculate their retirement years, like how many days are remaining. So I will say remaining years is equal to 65 minus a. Is this making sense? Um, so we accepted we asked for users age. Now we want to calculating like how many assets are remaining for their retirement, and for that we are doing the subtraction. Now this subtraction will not happen. This will give me an error. A reason, the cell is currently running. Let me just stop this. Okay. Oh, it's asking what is your age. I said okay, my age is 34. Now it gives an error. The error is saying the minus operator cannot support integer on one side and string on other side. So integer on one side and string on the other side. It is
We have to convert
yeah,
into
it
integer
is saying
type.
that a is a string. Okay, that's the problem. So any input that you give through your keyboard, by default, the system understands that the input is a string. It's not an integer. So now it us who we decide. Now we know that it user, when we ask user to enter their age, they are going to enter a numeric value, and
Sir,
next is
sir,
to we need to typecast that input value to integer. Yes, please go ahead.
sir, like a typecasting, sir. The compiler typecasting the
Yes,
string
yes,
into
this
integer.
is typecasting. This is typecasting,
Yes, sir. Yes, sir.
right? So the input that came from keyboard was a string input, and our expectation was a numeric value, so we typecasted that into an integer. Now we run this program. This is the same program that was here earlier. Run the program. What's your age? I say 32. Now it says you have 33 years remaining until your retirement. And this is all possible because we were able to typecast the input that was given by the user. Otherwise, we will not be able to apply this and mm, this minus operator here. Okay, is this part clear?
Yes, sir.
Okay, so we have
Yes, sir.
understood how input works, how typecasting works, how print operator works, and how these plus minus arithmetic operators work so far. Okay, here is a program. We need to program and ask user how much money they have, and accordingly we will tell how many Nintendo ways they can buy, they can afford. So to start with, we will first set the price of the object. Okay, so here is the first line of the code. Here we are setting the unit price of the V. So V price is 99 cents. Hmm? Now we will ask how many money the user have, and accordingly we will calculate how many they can buy. So user have one for one unit you need 99 cents. Now we'll run the program. Now we'll ask user how much money they have. The user says I have $1.98. The system will suggest you can this with this $1.98 you can afford 2 weeks. For example, run the program again, and if a user says that they have $3, so using this they can buy 3 V's, and then also they can save few 3 cents of their money. Okay. That's the this exercise question here on our screen. I'll share all this code with you at the end of the session. There is another Python program, easy one. Uh, Here we are asking the user which year they were born in, and accordingly we calculate their age. This is simple subtraction and very easy to do. Now, next part is a repetition, loop, and selection. There are two parts here. There are two parts in this repetition and selection. One is if else. If else are also called control flow statements, and loops, which are also called repetitions. Let's talk about for loop first. So for loop basically performs your instructions in repetition. So if you have given an instruction to the computer to perform something again and again, again and again,
Sir, you are not audible.
I'm sorry, thank you for reminding. I have been speaking currently. All right. So okay, next I'm going to introduce you to loops. Help you run the program in repetition. So if you want a certain set of instructions to repeat themselves, you can use loops. And selections, if you want to control how the program flow is working, you can use selections. I will show you both with examples. Let's first see how loop works. uh, One is for loop and other is while loop. Okay, so we are going to run this program here in our Google Colab editor. So I'm saying that for range 1 to 6, just print their square. That means from 1 to 6, print a square of all the value. So this is an example of for loop. This is going to perform our job and repetition. No problem, it is 6 or 36. It will always going to print, do the job. So it has printed from 1 to 6. It has given the square of all the values. You can increase this. Now let's see, 1 to 10. It has print square of all the values. Even 1 to 100 is going to do it. Okay, this is how it works. So simple code instruction, and it is going to repeat everything, run everything in loop. Mhm. In this loop example, we also use this function called range. Range basically is a mathematical function. It prints it gives you all the values in the range from start to stop. So if when we said range 1 to 100, it is going to give us a number from 1 to 100, all of the numbers. Let's also look at this in an example how range works. Sorry. Okay. In loops, there is also this thing called cumulative loops. So, comparing to the current loops, cumulative loops are going to use the variable which is initialized outside the loop. So, if you can see in this example, the variable which we are using inside the loop, this variable called sum, has been declared outside the function, outside the loop. So only only this area, which is highlighted area, is the loop. Okay, this sum equal to 0 is outside the loop, and print is also outside the loop. So such a loop is called cumulative loop. Why it is called cumulative? Because the loop is running from 1 to 11, but every time it is running, it's going to add or accumulate the value into the same variable. That's why it is called cumulative loop. At the end, it is going to print the uh, sum of the squares of number 1 to 10. Okay. Um, any questions in this program? All right.
Yes, sir.
Oh, yeah, please go ahead.
Sir, sir, in Java, we used to, if we, there is a sequence of number like in array from 1 to 10. If we want to add the odd element, odd numbers, we used to iterate the I plus 2 when we from the first. If we added the first element, then we have to
Mhm.
move to the third element. We use I plus 2, like that. In the range we can do like that, sir. So in the range, it's run from start position to the stop position, end position,
Right.
n minus one position.
Mhm. Yes, yes, that
I
is doable. That is doable in two ways. One is that if I, you can put if condition here. If I modulus two, uh, I modulus two, then this will do the sum only of only for the let's also not do, it will only do the sum of, sorry, it will only do the sum of the even numbers. Okay.
yes, sir, yes,
Um,
sir, yes, sir. Okay, sir.
if you want to don't want if you want the sum of odd numbers, you need to do if equal to 1, it will give the
Okay,
sum
sir.
of odd numbers. Okay.
Okay, sir. Thank you, sir. Thank you, sir.
Mhm. Next exercise question is to write a Python program to calculate factorial of a number. So we will define a factorial function first. Although the topic of function is covered later in this session, um, in detail. So I'll tell you for how this works. First, we are defining a function called factorial, and it accepts a number. All right. The first thing, if the number is zero, then the response is one. So it's a simple math rule. If the factorial of zero is one, and if it is not, then we go on calculating the factorial. Okay. We also have used try and catch, which is also a exception handling feature that we talk about later in this session. So let's run how this program works. First, we are asking, tell me a non-negative integer. So I tell it, so take 4. Hmm. So we all know factorials of 4 is going to be 24. And again, factorial of 5 is going to be 120. Now let's understand the program with the help of 4, with the help of 5. When we pass 5 here, when 5 comes here, 5 is not equals to 0. Okay. So this if block is ignored. We enter into the else block. Inside else block, the 5 is multiplied by 5, and the 5 is multiplied by the factorial of 4. And then how factorial of 4 is works, then factorial of 4 is going to be multiplied by 4 into factorial of 3. So that is how 5 into 4 into 3 into 2 into 1, that is how the response finally comes to 120. The program is on your screen. Try to read the lines, and if there is any point you want to ask question, please feel free to ask. All right, let's move to the next part of the program. Control flow statements. Although this in sequence came later, we already use this in our programs here in Factorial and also earlier in printing the even numbers. So let me show you a small example how to demonstrate how this if conditions work here in Python. So yeah, put very simple. I say for this number, let me take for numbers between 1 to 11, we need to print only the even numbers. We will say print I. Okay. Hold on. Let's first print I. Then we know print I. Okay, it prints all the number from 1 to 10, and 1 modulus 2 is 1 modulus 2 is 1. Oh yeah, right. So this is going to print all the even numbers. Sorry, all the odd numbers. And if we want to print all the odd numbers and all the even numbers, we need to say this. Simply put, I modulus 2 means any number divided by 2, and if the remainder is 0, okay, we are saying if the remainder is 0, this if condition is checking. If after dividing the number by 2, if the remainder is 0, then print that number. So these are the numbers from 2, 4, 6, 8, and 10. When these numbers are divided by 2, the remainder are 0, and the numbers are printed. And now we change, if the number divide a number by 2, and if the remainder is 1, print 1. So this will print all the odd numbers. Okay. Um, any questions here about conditions or loops?
No, sir.
Anyone?
No, sir.
All right. Now we are up to a position where we can make a simple game using Python, a very simple one. So we have learned the looping concepts. We have also learned the mathematical functions a little bit, and also we know how to learn loops and conditions. So let's look at this example. So we have this function. We have this program. What this program is going to do, let me first explain the program, then okay. So this program demonstrates guessing game. So when you are small, you must be playing this game. uh, like one person is going to think of a number, and other person is going to guess the number, and how many attempts they make to guess the number, their score depends upon that. So let me first demonstrate how this program is going to work. So the computer has guessed a number between 1 and 10. Huh? Now it is asking me what is my now I have to guess what number the system is thinking between 1 and 10. So I will always guess 5 because that's the middle number, and it's easy to score better if you start from 5. It says no, the number in computer's mind is less than 5. So less than 5, I will go for another middle number, that is 3. It is say still lower. So less than 3 is only 1 and 2. So let's see our luck. Yes. So in 3 guess, I know what what the computer was thinking. Let's run the program again. Ah, the system has already decided a number between 1 and 10. Now I have to guess the number. So I will again start from 5 because that's the easiest way I can quickly do it. So it says at higher number, huh? From 5, I will go for 8, higher number. Now there is only two options, 9 and 10. So let me guess 10. Oh, 9. Okay. I took 4 chances to guess the answer correctly. This is a simple game that you can make using Python, not knowing all the concepts, just by knowing the loops and condition statements. The program is here on your screen. Take a moment, read the program, and let me know if you need, at any point, if you need help understanding it. A variable target number is the number that computer has in its mind, and guesses is the number of guesses that we are doing, like how many tries, how many attempts we are doing. That is the number variable guesses. And user guess is the actual number that you input through keyboard. And when the user guess is equal to target number, you win the game. And until that happens, it's keep on iterating. So if you must be seeing that when the user guess the correct number, there is this statement called break. This break is going to end the loop. And until the user guesses the correct number, this loops keeps running, iterating again and again, again and again. Any questions till this point? All right, I'll send you all these programs at the end of the session. Okay. There are this couple of logic operators we have in Python. They are very much like mathematical operators. So when two equals are used, these are used to compare the value of two values. This is not equal, which is again used to compare the values. Less than, greater than, less than or greater than, or less than, greater than, equal to. So all of these operators are always going to return a Boolean value. Boolean means true or false. Let me give you an example here. So if I say a equal to 9, a equals 9, and b equals 7 multiplied 2, and now we need to compare, are a and b equal? So it is saying false, which means 9 and 14 are not equals. Now let me say, if I say is a less than b, is a less than b, then it will say true because 9 is less than 14. This is how these operators work. Now, logical operators can also be combined in themselves. For example, you can check two conditions. Now, if I want to check if A is less than B and A is more than 0. For example, we need to check that A should be less than B and also a positive number. So it will say true. A is a positive number and A is also less than B. If I say A is more than B and a positive number, it will say false. Okay, so this is how the logical operators in Python work. And operator, if both sides are true, then only true. Or operator, if any side, if any of the operand, any side is true, it is going to give us true. Sorry. And not is going to give us the opposite result. For example, if I say not, simply put, like not, maybe next one, not true is false and not false is true. Hmm? If I say 24, 20, let's say 24 modulus 2, we know 24 modulus 2 is 0. Okay, and if I compare that with 1, it should be false. Simply, if we say 24 modulus 2, we know 24 modulus 2 is 0. And if we say 0 is not equals to 2, 1, it's going to say, yes, it is true. It's not equal to 1. This is how logical operators work in Python. We have these three control statements while we are using loops: break, continue, and pass. So one of these we saw in our examples here. We used break. In this game example, guessing game example. So the loop is continuously running, and it will run till the point you guess the correct number. And when you guess the correct number, it is the break operator is going to break the loop, and the loop will stop at that point. All right. Till this point, um, any questions, doubts? Because next we are moving to data types. These are not simple data types, they are like complex data types. So before that, any doubts or questions till this point, please go ahead and ask. I will pause here for 2 minutes.
No, sir.
Okay, thanks Prakash for confirmation. Anyone? Gautam, do you have a question?
No, sir.
No, sir.
No, sir.
Thank you for confirmation, Praveen. Thanks for confirmation, Gautam. All right, thanks for confirmation, Sonu. Nice. Let's move to the complex data types part now. So difference between simple data types and complex data type is that simple one, you can store one value in a variable. Complex data types, you can store multiple values inside same variable. Let's see how this works. Yeah. Um, for example, we had a question about this earlier, about integers. So we have a integer and long integer, and integer has its boundation and long integer is unbound. You can store any value when you have a long integer. The good thing is that you don't have to worry about it. Python takes care of it automatically. So the comparison you did was with Java. So in Java, you need declare a variable telling what type of variable it is, right? You tell int a is equal to something. In Python, you don't. You just declare a variable without telling what the type is. So you assign the value, Python will take care of it, what type data type it is going to be. Simply, we also have floating point variables here. But again, you don't have to worry about giving any variables, any data type to the any variable. All variables are like weakly typed here. They don't need a data types. Sorry, yeah. We have also complex numbers in Python. S- Only language probably where you have a complex number built in into Python. And plus minus operator all going to work on complex number. So complex number in Python have two parts. One is the real part and other has the imaginary part. So if the complex number is defined as x is equal to 3 plus 2j, this is a complex number. X is equal to 3 plus 2j. What happened to you? Okay, so this is how we define. So this 3 is a real part and 2j is the imaginary part. And normally in your school, in your mathematics, you would represent this as 3 plus 2i. I stands for imaginary. But in Python, we use, instead of I, we use j to denote this. All right. So this is one complex number, 3 plus 2j. Let's define another complex number, that is 1 plus 6j, maybe. Yeah. Now let's do a sum of both x plus y and what the output is. Y is not defined. Okay, this cell didn't run. Okay, so the sum is 4 plus 8j. The real part of the two numbers got summed together, 3 plus 1, 4. And the imaginary part of the two numbers, 2j plus 6j, they got summed together and they become 8j. This is how the operations work in complex numbers. Complex number sum is also possible, multiplication is also possible, square is also possible. String literals, we have seen in examples how this works. In Python, you can also use plus operator to combine or to concatenate two strings. Okay, we have got some string methods like length and substring, very important things to know. This help you do the uh, slicing and joining the strings. Formatting of string, all of this we have already used in our examples before, and now we are only looking at them as a concepts. um, the important thing now to note is that the amount of data collection, the data structures that we have in Python. After knowing the simple data types, now let's come to the complex ones: set, list, and dictionary. Now you need to visualize how these data structures in Python work. List is a simple, if those who are coming from Java background or know Java programming or C programming at least, uh, in other languages we have this thing called array, and that array becomes list here. So how this list works is, you store multiple elements in as a list, and every element has got an index that helps us identify the particular value. Okay, let me show this with an example. If I say list of fruits, apple, banana, grapes. Okay, this is how it works. So we have defined list of fruits, apple, banana, and grapes. Earlier, you had seen that in one variable we stored just one value. Now this list is going to allow me to store multiple values into same variable. You want to see how this looks like after printing? Okay, a single variable, multiple values. This is how list is. Now let's see how we access the individual elements of this list. For example, if we want one of these items, not all. If I want to access one of the elements, list of fruits, I say the first element I want to access, I will say 0 index. The first element is apple. Okay. Second element we will say index 1. Third element index 2. Okay. And let's try to access something which doesn't exist. It's an error. Index out of range. So this error is because there are no 5 elements. If there are 5 elements in this array, it will print the index 4. And index are 0 bound. For example, this means that first element is 0, second is 1, and third is 2. That is how it works. We can also use this indexing to modify the elements. So currently this list of fruit has apple, banana, and grapes. Let's change element number 2. Element number 2 is grapes, and change it to orange. Yes, or orange. Okay, we did this. Now let's print the list of fruits again. Okay, apple, banana, and orange. Grapes had changed. Look at this code, 99 and this 99 to 107. Any questions? Let me know. You can also use this to print the value in loop for UIT fruit and list of fruits. Print fruit.
Sir,
Yeah, please.
sir, how long is the session gonna last?
We have a couple more topics remaining.
Okay, okay.
Yeah. All right. This was about list. Next, we have sets and dictionary. Oh yeah. So important things. List have some inbuilt functions. We won't be able to cover all the functions here, but some of them let's try. Okay. So if you want to add a new item into the list, you can simply say list of fruits dot append.
Will you share the document after this session?
Yes, yes. I'll share you the document as well as the codes.
Okay.
And after appending, we say list of fruits. The one new item has been appended. If you want to remove one item, you can simply say list of fruits dot. This is going to remove one of the items from the list. Now we print the fruit list. It is going to print only 3 items. Okay, we have covered this. Using list like a stack, you can use append and pop functions. Tuple are like very much a variable where you can store two values separated by comma and bound in a bracket. So for example, x is equal to 2.3. So this is called a tuple. One of the useful part is sets. Sets is a list of values, but there are no duplicates here. So there are multiple real life examples of sets, and one of the very useful data types we have is sets. So let me give you this example from sets, and I need to insert a code cell. I got sets. Okay, the first set is A, B, C, D, and second set is C, D, E, F. Now, when we say set A minus B, this is going to remove all the elements in A which also exist in B. So A, B, C, D minus C, D, E, F is going to give us A and B. C and D will be removed. Hmm. Similarly, if I do a union of both, so it is going to combine both the sets A, B, C, D, C, D, E, F. As when combined, it is going to become A, B, C, D, E, and F. We can also do an intersection of both. So when you do intersection of both, so only the common elements will be printed. And there you can also do this anti-intersection. So everything will be printed except the common elements. These are the 4 set operations we have in Python. Very important. Next is dictionary. Dictionary are basically key value pair. So if you have a background in JavaScript or other languages, you must be knowing that class and objects exist there. So dictionary are very much like that object. So let me show you this with an example quickly. So this is an example of how dictionary is going to look like. So here Wayne, John, and Mary are key, and this is their value. So we are going to use store address of 3 people this way. This is a dictionary. Hmm. You want to print them, you want to iterate over them. It's simple. You can do it using for operator. There are functions, dictionary elements. For example, you want to delete certain elements, you can use del function. Hmm. Certain operations that you can perform over dictionary and list are listed here. So finally, a simple summary about data types. We have got integer, floating point number, complex number, list, tuple, and dictionary. All of these are very important. And like this completes the fundamentals of Python. Last thing in Python is we have is functions. Any questions till this point? Then we move to functions.
No, we cannot.
Okay, thanks for confirming. Anybody has any questions? Aniket, Prakash, Gautam,
No,
Sonu.
no, sir.
Please do respond, everyone. If you have any doubts, please ask.
All right, let's move to the next part, functions, and very important and crucial part. Why we need functions in the first place is that we want to avoid we want to avoid repeating the same set of code and again. So one of the very important programming principle is that you should not be repeating the same code statement again. Um, yeah, that's called a DRY principle. Do not repeat yourself twice. So to be able,
Dynamic programming.
yes, right, Gautam. So the functions helps you save that. So if any set of instructions, if you want that to make it reusable, make it a function. Okay, we have already used functions in our examples above, multiple examples above. For example, this factorial one. This is a functions we have. This is a function we have defined. So in Python, how we define function, we first use this def keyword. This tells us that you are defining a function, and then give a name to the function, and then inside a bracket we give argument to the function. Hmm? Below that, you do operations, you write your set of instructions, and then finally there is a return statement. Return statement actually gives the response or output from the function. So here in front of your screen, there is a simple function, factorial function. Take a look at it. And now let's see how this function is used later. This is on the top, it is defined. After defining the function, next is to use the function. To be able to use the function, you need to call the function somewhere with the same parameter. In this program, the function is being called inside its own body also, and also being called here as right here in the place. So when the function is called, it expects an argument, which is a number in this example, and also it returns some value. When it value is returned, you need to store the value somewhere in a variable, as you can see in this example. Another example of function we have in our program. Um, okay, we don't have any. Factorial is the only one. Yeah. Okay. So far we have used only one program with function. Hmm. Uh, so as I told you in the previous example, a function can take parameters. So everything which are inside the bracket are called parameters. And function can also return values. So inside the function, you will always find this return. So this parameter are basically input inside the function, and return are basically the output from that particular block of the function. We are not covering how high order functions today. We are only focusing on about the fundamentals. Now let's talk about the function inside function. In Python, that is also possible. You can define a function that is called parent function, and you can also define child functions inside it. Okay. Interestingly, Python also allows you to define default parameters. For example, here is an example given here. You are defining a function. Name of the function is foo, and you are giving a default parameter as 3, x is equal to 3. Now, when you call the function here, foo, there is the two way you can call it. You can pass a value inside it. If you pass the value, then fine. The value that you are giving will be considered. If you don't pass a value, if you don't give an argument, the value which is defined as at the time of definition will be taken. For example, in the first call, we are calling the function foo, and we are not passing any value to it. So it's taking 3 as the default value. Where in second call, we are passing the value 10 inside it, and because of which 3 is ignored and 10 is considered. In third example, the function is called and the value given here is hello. So the default value 3 is ignored, and the hello is taken, it takes the precedence. Okay, that's what it is explained here. If you pass the parameter a value, the original value is overwritten, and when you don't pass the parameter, the what is the default value is takes care of the requirement. Hmm? You can also pass parameter to the function using named parameters. So let me quickly make a function program here in Okay, so I'm defining function def sum a equal to 10 and b equal to 2. A return a plus b. Now there are multiple ways we can call this function. A comma b comma c. Okay. Um, okay. Let's keep it simple. Let's say print. Okay. So here we defined a function a is equal to 10 and b is equal to 2. These two default values are given. Now, if we want to override this value, we can say a is equal to 9 and b is equal to 0. So this will give the sum of the values we pass. If we don't want to override the value, we can simply call the function and it will take the default values and sum them. This is how this is how the default parameters and named parameters in functions work. Anonymous function, we are not covering it today. And that's all. This is all the for this session of the Python. So far we have covered Python. We have covered data operators, data types, variables, list, complex data types like list, dictionaries, tuples, sets, and loops, control statements, and functions. A lot of things to cover in 90 minutes. I might not have done justice to all the topics. But yeah, feel free to ask the questions. We have got another 10 minutes for questions only. I will be sending you this presentation as well as the programs and codes that we made in this session of the learning. Any questions related to any of the topic from beginning to end, or general queries about programming Python, just let me know. The floor is open
Sir,
for
I have a
questions.
general question to ask you.
Yeah, please go ahead.
Sir, which programming language comes really handy in corporate jobs and all?
Mm, well, the two, Python being one and JavaScript being the other. Yeah, in last 5 years, these two languages have grown a lot. Hmm. But yeah, it doesn't mean that others are not important or relevant. They still are. Does this answer your question?
Yes, sir. Thank you.
Thank you, Aniket. Okay, fine. Any question at any point of the time, feel free to reach me out. Um, Let me share you my email ID and also my LinkedIn connection URL. So if you face any problems, any queries related to your learning, programming, or any question related for your mm, related to your career choice, career growth, feel free to send your questions to me. I will be available to answer your questions on LinkedIn and email. I've sent the details here. I have everyone's
Sure, sir.
email ID. I will send you the material that we have discussed. Thank you, everyone. Thanks, Aniket, Gautam, Gavaskar, Prakash, Praveen, Abhishekta, everyone for the joining the session today. Wish you good luck and
Thank
great
you,
day.
sir.
Bye.
Thank you, Vikas, for this wonderful session, and thank you everyone for joining.
Thank you.
Thanks to Vikas and Kakoli.
Bye.
Thanks, everyone.
It was a nice session.
Thank you, Gautam.
Thank you.